Hello everyone, welcome back to the series of complete DSA using Python specially designed for GATE DA exam. In this session, we will cover various complexity functions, actually growth of those complexity functions. For example, constant function is there, n log n square, there are many complexity functions are there. We will see which function is growing faster, which function is growing less when we are giving some input to that function. We will compare them and we will see which is taking more time, which is taking less time. So there are many questions asked in GATE exam from last 30 years. If you will check out, they are coming from this topic itself. And after this session, you will be able to solve all those GATE questions. Fine, okay. Let's start with the growth of complexity functions, how they are growing, which is faster, which is slower, and so on. We will see in this session. There are some of these are standard complexity function I have written over here, like constant, log n, root n, n square, n power 3, n power n. These are some standard complexity functions, and you can see directly the growth of these complexity function in this graph. As you are increasing the input, how they are behaving, how much time they are taking. So this is shown over here. You can see that, okay, as we are increasing the input, constant function is not impacted, that is taking fixed amount of time, fixed straight line is going on. Constant take the minimum time to execute. I don't know how much input you are giving up to infinity, this will take fixed amount of time, this will take minimum time. N power n is taking the maximum time, that is just growing very fast. As the input is increasing little bit for little bit input, the time taken is very large, that is increasing with very high speed, and all these functions are lie in between. So log n is taking more time than constant, root n is taking more time than log n is taking more time than root n square is greater than n cube is greater than n square, and n power n is greater than n cube. So these are some standard complexity function. To solve the GATE questions, these growth rate must be in your mind. This graph should be in your mind, that okay, which function is greater, which function is smaller. I'm adding some more important functions in this graph. Okay, these are some standard complexity function that definitely should be in your brain. Let me add some more in this graph. For example, I'm making a growth rate for another function, that is log of log n. Log of log n. This complexity function is another popular complexity function. This is taking more time than constant. Actually, every function takes more time than the constant, but less than the log n. So this is less as compared to log n. This will take less time. You can see if the input will increase, input size will increase, this is growing with less speed as compared to this log n, taking less time. If you will see this y-axis. So log n is greater than the log of log n. Although you can see whenever you take the log of something, so the value get reduced. So here you have just log and you are taking further log of log n. So definitely this value will be smaller. Another popular complexity function I can add over here is the n log n. So n log n will lie here in between n and n square. So let me write n log n. N log n is taking more time than n. Definitely you are multiplying n with another function log n. So n log n is greater than n, but smaller than n square. Let me add some more important complexity function, very popular one. So here I can add one is 2 power n. So 2 power n is greater than n cube, but smaller than n power n. Okay. Fine, okay. So these are some standard complexity function. These must be in your brain whenever you are solving the GATE questions. This graph, this chart must be in your brain. And there are many other type of complexity function they will make by combining these standard complexity functions. They will make new complexity functions, and they will ask which is growing faster, which is growing less speed, okay, which is taking less time. Those we can find out by using some techniques I will share with you people, but this thing should be in your brain even to apply those methods. Okay, that will make your life easy if you know this chart. Who's growing faster, who's growing with less speed. Fine, okay. I'm moving on, erasing it. Now let's see the various method to compare the complexity function. Okay, we want to know which is growing faster, which is growing with less speed, taking less time. So I'm sharing one informal method with you. Informal method. This is informal method, means this is not a standard method, but this method works and solve each and every type of problem. With the help of this method, you will be able to find out which complexity function is greater, which is smaller. You will be easily able to find out. So let me share. There are 3 steps you need to perform in this method. First step is that, okay, you will remove common term in 2 complexity functions. If you're comparing 2 complexity functions, you need to remove the common term and then you need to check, okay, which one is greater, which one is smaller. So this is the first step you can make. Maybe you can get the answer just after applying the first step. But if you are not getting the answer after applying first step, you can move to the second one. In second one, what you can do, you can apply the log both side. Apply log both side. Means at first function also and second function also apply the log and then check out who is greater, who is smaller. If still you are not able to find out which is greater, which is smaller, third step you can move on. Put some large input value. Put large input value. So if you will put some large input value, and then you will find out, okay, which is taking less time, which is taking more time, you can easily find out. So just apply these 3 steps and you will be definitely able to find out which function is growing faster, which function is growing slower. Here one important point you need to note down, that we don't need to apply all these steps. Maybe we can find the solution by first step. If we are able to find the solution by first step, then why we should go to the second one? But if you are not able to find with the first one, then go to the second one. And if you are not able to find with the second one, then go to the third one. Okay, so no need to apply all the 3 steps. Maybe we can get the answer just applying 1 step or 2 steps. Second thing you need to note down here is that, see, these 3 steps must be applied in sequence only. Sequence. You cannot apply the second step before the first step. So if you will apply the second step before the first step, you might get the wrong answer. Fine, okay. So let me take some example and apply this informal method. Let me take my first example. For example, I want to compare n square with n. I want to know which is greater, which is smaller out of these 2 functions, n square and n. So let me apply my informal method to find out this. First step says that remove the common term. Is there any common term this side and this side? Yes. Actually, n square is nothing but n into n. And this is n only. Okay. So n is common. N is common both sides. Okay. So what is left this side? N, and what is left this side? 1. So you can multiply it with 1. So here is 1. Now you can easily find out that, okay, n is greater than 1. N is greater than 1. So you can say that yes, n square is greater than n. So simply by applying the first step itself, we find out which is greater, n square or n. Fine, I just take one easy example. Please note down that, okay, if you will apply the second step before the first step, you might get the wrong answer. So let me apply here and let me show you. If you will apply, let me apply over here. So you have n square and n. If you will apply the log both side, here n square and here log of n. So you know that what is the formula for log? Whatever is the power that will come in the front. So this will be 2 into log n, and here is log n. We apply log both side, and then we will compare. Constant thing you can remove. Okay. Now you see, here is also log n, here is also log n. I apply the second step directly. And this is telling me that, okay, both are equal, both are log n. Both are log n means both are equal. But n square is not equal to n square is not equal to n square is greater than n. So this is giving me wrong answer when I apply the second step. So see, I apply the second step directly without applying the first step. If there is something common both sides, we need to remove that. We need to remove from both the side. This is must to apply the first step before applying the second step. Otherwise, in many cases, you will get the wrong answer. Like here, you are getting equal value, both side log, and they are not equal. They are not equal because I do not remove the common term. I just apply the log both side directly. So please make sure apply the first step, then move to the second step. Remove the common term both side, then only apply the log. Otherwise, you can get the wrong answer. And if you are not getting the right answer, still not right answer, if you are not able to understand which is greater, which is smaller, still after applying the second step, you can go to the third step. You can put some large value in place of n and you can see which is taking more time. You can calculate. Okay, fine. Okay, so this is the informal method which you can apply and you can find out which function is smaller, which function is greater. Let me share another method also which can be helpful for us to solve some of the problems. Okay, second method. Otherwise, first method, this informal method will work everywhere. Even you don't need the second method, but this second method will make our life little more easier. Okay, so let me tell you what is the second method. Second method simply says that if we have some function in the form of power, for example, I have n power log n. This is one function. Another function is n power root n. Okay, so I have the function in the form of power. You have power in the function. Then what you can do simply, first check out the base. If the base is same, yes, here n and n is same. If base is same, no need to apply the informal method, nothing. If base is same, then just simply compare the power. Which power is greater, that function will be greater. Because base is same, n and n both side, simply compare the power. So which power is greater, that function will be greater. That function, here you can see that, okay, root n is actually greater than log n. Root n is greater than log n. So this function is greater than this function. Okay, simply second method says that if the base is same, then compare the power. Okay, if base is not same, then apply the informal method. Okay, even some people don't know how this is greater than this, so I can apply the informal method. What informal method says that, okay, can you cut something common both side? No, there is nothing common both side. So first step cannot be applied of informal method. I'm applying informal method now, first method. So in first method, first step cannot be applied because there is nothing common both side. Now I can take log. So this thing I can write like this also, n power 1 by 2, and this is log n only. So if I take log both side, second step, because first step I cannot apply, there is nothing common both side. This is n power 1 by 2 and this is I will take log of log n. Okay, and whatever is in the power, that will come in the front. So this will be 1 by 2 into log n. And here we have log of log n. Constant you can remove. So which is greater, log n or log of log n? If you remember the chart, first slide itself, log n is greater than log of log n. Log n is greater than log of log n because you are further taking log of log n. So log reduce the value further. So this is greater. You can see that this is greater than this. Okay, fine. Okay, so these are the two methods we will use and you will be able to solve all the last 30-year PYQs just by using these two methods. Okay, you can compare which function is greater, which one function is smaller. You can solve each and every question. Fine, I'm taking some example over here, some practice questions, and we will solve the GATE DA practice question here itself, in this session itself. But one advice from my side, please pause the video. If you really want effective learning, if you really want to improve yourself, then please pause the video and try this question yourself. Definitely I'm solving at my end, but you also try it. Okay, first you try it, then you can check out the solution. Okay, let's move on. So let's start with the first GATE CS 2017 question. Let me read the problem statement. Consider the following functions. So for some functions are given to us like 10, which is a constant, root n, log n, and 100 by n. So some functions are given to us and we need to arrange them in increasing order. Okay, so like first smaller function, then greater than greater than greater. So whichever you can compare easily, first you can compare those, and then which you cannot compare, you can apply the informal method. Let me see. This function you already know from the chart, actually the chart which I show you in the first slide. You know that n is greater than root n and root n is greater than log n. Okay, so please keep remember that chart. That chart will make your life more easy. Now after this, if you want to compare this 10 and 100 by n, this is little tricky. Okay, which is greater, 10 or 100 by n? So here actually 10 is greater than 100 by n, because as the n value will increase, n tends to infinity. So as you will put the larger and larger value of n, this will become smaller and smaller, but this will remain constant, that is 10. So even this will be smaller than 10. Okay, as you will increase the n. So in asymptotic notations, n tends to infinity. So this is smaller than this, and this is a constant which is smaller than log n itself. So I can write it like this way. So this is the combination I can make, 100 by n. So you can see over here, this is the smallest one, then this is greater than this, then log n, and then root n, and then n. So let's see which is the right arrangement over here. If you will match starting from this side, then B is the right answer. 100 by n, constant, log n, root n, n. So let me see, B is the right answer or not. Yes, B is the right answer over here. Fine, okay. Any doubt is coming, write in the comment section. I will definitely reply over there. Otherwise, let me move on to the next question. So next question is from GATE 2001. Let me read the problem statement. Let fn equal to n square log n. One function fn is given. Another function gn is given, that is n into log n power 10. We need to find out which of the following statement is true. Okay, based upon these two functions, we need to find out which statement is true. Okay, let me compare these two functions first. N square log n, and another function is n into log n power 10. So let me compare these two functions and find out which is greater, which is smaller. So I am applying the informal method. In informal method, first we need to remove the common term both sides. So here we have n square, n into n. Here we have n. So I can remove one n from here and one n from here. Here we have log n power 10. Here we have log n. So remove this log n with one log n from here. So what we left over here, n, and what we left over here, log n power 9. Now if you're not sure which one is greater, which one is smaller, second step you can apply. We remove the common terms. Now apply the log both side. So I'm applying the log here and log here, both side. So power will come in the front. This will be 9 into log of log n, and here we have log n. So constant you can remove and you can compare which is greater, log n or log of log n. We know that from the table, from the chart itself, log n is greater than log of log n. Okay, so this function I can say, okay, fn is greater than gn. This thing we know now. This thing we know. Based upon this, let's see which relation is right. Big O, we know that in big O, right hand side will be greater than equal to left hand side. So right hand side should be greater. So gn is greater than fn. Gn is not greater than fn. So this statement is wrong. What about this one? This is saying gn is not greater than fn. Yes, this statement is right. Here is saying that Fn is greater than Gn. Yes, Fn is greater than Gn. B is the right answer actually. Let me check out other also. Gn is greater than Fn. No, Gn is not greater than Fn. Gn is not greater than Fn. Gn is not greater than Fn. Yes. Fn is not greater than Gn. No. Fn is greater than Gn. So B should be the right answer over here. Let me check out. Yeah, B is the right answer over here. Fine, okay, let me erase the board and move on to the next problem. So this is GATE CS 1996 problem. Let me read this problem. Which of the following is false? Which statement is false? We need to find out. So here it written 100 n log n equal to big O of n log n by 100. See, remove the constant first of all. I'm removing this 100 and this 100. Now what is left over here? N log n. What is left this side? N log n. Both side equal. Big O notations says that okay, left hand side is less than equal to right hand side. So equal to is also allowed. So I can represent n log n equal to big O of n log n. That is allowed. So this statement is true. But we need to find out that statement which is false. So okay, let me check out the second option. Here we have root of log n. Here we have log of log n. You can directly also find out this. Okay, you are taking log of log n. You are taking log of log n. Some value you can say. Okay, if you put log n as a x, so it's like this. Log of x. Log of x you are taking. Here root of x you are taking. So root of x and log of x. Now you know which one is greater, which one is smaller. You know that root is greater than log. Okay, so this is greater than this, but okay, we are representing with big O. That is actually false. In big O, right hand side can be greater or equal to, but here left hand side is greater. Root of log n is greater than log of log n. So this statement is false, and this must be our answer because we are looking for the false statement. But let me check out the other option also. Here this is saying that okay, y is greater than x, x is greater than 0. Okay, then what about this statement? See, n and n are same. Power, you can see y is greater than x. Here they are giving y is greater than x. So definitely right hand side is greater than left hand side. Yes, we can represent it with big O. This statement is true, but we are looking for the false statement. So this is not our answer. What about this one? Here k is constant, n power k is given, here 2 power n is given. They are saying they are not equal. They are not. We cannot represent it like this. So if this is actually polynomial, if we have something in the power of n, constant something we have in the power of some value or some variable, that is a polynomial. Polynomials are smaller than exponential. Okay, so this is exponential. Okay, actually this statement is true. This statement is true. This is greater than this. Actually this is greater than this. So this statement, and they are saying this is not equal to. Yes, so this statement is true, but we are looking for the false, and false statement is one only over here, B. So B must be the right answer over here. So let me see. Yeah, B is the right answer over here. So let me move on. That's it actually for this session. Stay tuned. We will meet back in next class.